Now getting into some specific properties of exponents. One of the properties of exponents is the zero exponent, and it would look like this. The zero exponent property basically states anything other than 0 to the 0 power is always equal to 1. Again, anything other than 0. So a cannot be equal to 0. But regardless of what a is, as long as a is not 0, again, anything to the 0 power is 1. Again, anything other than 0 is to the 0 power is 1. So 5 to the 0 power, that should be 1. And then you could even try that on your calculator. 5 to the 0 power on your calculator would give you 1. As long as x is not equal to 0, x to the 0 power would be 1. Negative 23 to the 0 power would be 1. As long as you enter it in your calculator exactly like this. This right here, negative 23 to the 0 power, is actually different. 23 to the 0 power is actually 1, but then this says take the opposite of that. So that would be negative 1. So be careful there. You have to be using the correct order of operations or PEMDAS, because if you have an expression like this, this would actually be the same as negative 1 times 23 to the 0 power, where you would use exponents before multiplication. In PEMDAS, your order of operations, exponents come before multiplication. So if you do something like this on your calculator, you need to make sure you put the negative 23 in parentheses. It's still true that anything to the 0 power is 1. If you tried 0 to the 0 power, that's actually undefined. So I said anything to the 0 power other than 0 is 1. Okay, that's kind of a special case. So if you entered this on your calculator, it might say something like error. It might say something like 0 power error, something like that, but it's undefined. And then a second property of exponents that you'll need to know is your negative exponents. So if you have any negative exponent, for example, a to the negative n power, as long as a is not equal to 0, whenever we're taking any exponents or properties of exponents, we're assuming that the base is not equal to 0. But a to the negative n power, that's defined to be the reciprocal. So a to the negative n power with any negative exponents. If you're asked to simplify, which is what you'll be asked to be doing, you actually never want to leave any negative exponents in your answer. It would be incorrect. But a to the negative n power, you want to take the reciprocal. You want to make the negative exponent positive. That's defined to be 1 over a to the nth power. And then we'll go over some examples of that. Now looking at some examples with negative exponents, 3 to the negative second power. So you always want to take the reciprocal. Again, you always want to make the negative exponent positive somehow. The reciprocal of 3 is 1/3. So 3 to the negative second would be the same as 1 over 3 squared. That's taking the reciprocal. Or another way of stating it is this exponent right here in the negative 2, the 3 is actually in the numerator because 3 is the same as 3 over 1. So to make the negative exponent positive, you take the reciprocal, which means put the base in the opposite place. The opposite of the numerator is the denominator, 1 over 3 squared. And then you could actually simplify that. 3 squared is 9, not 6. Remember, 3 squared is the same as 3 times 3. You want to multiply the base by itself. You don't want to multiply the base by the exponent. Some people get confused and then try to do that. So it would be 1/9 in simplified form. And then 8 to the negative fourth power. And this 8 is basically in the numerator. You want to make the negative exponent positive. And how you make it positive is by putting it in the denominator. That would be 1 over 8 to the fourth power. And then you'll probably need your calculator to evaluate 8 to the fourth. You could break it up. 8 times 8 is 64. And then you would actually multiply that by 64 as well, because that would be 8 times 8. 8 to the fourth power. Again, you might just need to use your calculator for that, but 8 to the fourth power is 4,096. That would be in the denominator or on the bottom, and then what would be in the numerator is 1. And then for our third example here, what's being raised to the negative third power is negative 2. That's basically in the numerator, so to make the exponent positive, you put it in the denominator. So that'd be negative 2 to the third power, 1 over 2 to the negative 2 to the third power. If you do this on your calculator, here's what's going on. It'd be negative 2 times negative 2, which is positive 4, times negative 2 once more. So that's a positive times a negative. It's a negative. And then that'd be negative 8. So 1 over negative 8, which is just negative 1/8. If you have a negative base to an odd exponent, which is what I have here, then it's going to be a negative number. If this were to the fourth power, I'd be multiplying a negative by itself 4 times. That would be a positive number. If you kind of forget that, then I would suggest just using a calculator. But make sure if you're using a calculator, you're putting a negative 2 in the parentheses when you're raising that to the third power. Okay, and then the last example here, this 5 to the negative second power, this is in the denominator. So to make it positive, which is what I want to do, I'm going to bring it to the numerator. That'd be the same as 5 squared or 5 squared over 1. You could write it either way. But this base right here is to a negative exponent in the denominator. I want to make it positive as far as the exponent. So you bring it to the numerator. And then 5 squared is 25.